Maybe you've seen something like this. This is a ruler, but it's also technically a PCB. It doesn't do any electrical functions, but it has a whole bunch of footprints for various components and some useful information. This one was made by Adafruit and is a pretty handy object, but I decided that I want to make my own with the features that I want. If we look on DigiKey, for example, we have the Adafruit part I just demonstrated, as well as quite a few others, each with their own different features. But I wanted to take this as an opportunity to design my own with the features that I want, and in the process get to know KiCad, which is an open source and free electronics design software, and use this to learn to make a PCB from start to finish. When you first open up KiCad, you'll get a screen that looks a bit like this. This is your main overview type menu. This is where you can create new projects, as well as create and edit new libraries for your symbols and your footprints. I'm going to create a new blank project. In this folder, PCB ruler, and just call it PCB ruler, ruler. So that's created a new PCB file and schematic file. If we open up the schematic file, you'll see it's a blank page with an empty title block. First thing we can do is fill in some of the details of the title block by double clicking on it. And I'm going to click export to other sheets so that if I create more pages, this will automatically fill in those. Now, first things first, we should set our grid to be a nice value. I'm going to go view and make mine millimeters, and then grid properties, and I prefer to use this sized grid, 10 mils or 0.25 millimeters. You can set it to whatever you like, this is just what I prefer. Now we're ready to start placing components. So we're going to go to add a symbol. This brings up the symbol library, where you can see there's hundreds of different components in here of different categories. I'm going to type resistor and see what resistor options there are, because I want to start with placing surface mount resistors for a variety of common sizes. Here's resistor, and we'll click the default footprint button and find the footprint that we want. Let's start with a 0402, and I'll place that there. Now that I've done that, I'm going to start placing other components to make up the footprints that I'd like to see on my PCB ruler. I have a list already, so I'm going to go ahead and populate the schematic. Now I've put together a schematic with different parts that I want to include on my PCB ruler. These have different footprints, so they'll show up when we start the PCB layout. But let's say I want to add a component that's not in the library. For example, a Nixie tube. I might want to use one of these for a future project, but it's not in the standard library. It comes up with nothing at all. In this case, we'll have to design our own part. So to do that, we'll go back to the project menu, click on symbol editor. Here I'm going to create a new library for the project only, and call it Nixie tube. And that's created the new library here. And now we right click on that and go new symbol, and I'm going to create an IN16 sized Nixie tube. I'll leave the designator as U for now, fix that later if I need to. And here we go, here's the new component. Now I happen to have a datasheet for an IN16 Nixie tube here, which shows us this image of the tube symbol as well as the pinout. I'm going to try to recreate that in a nice neat way in KiCad so that we can use that as a symbol on our schematic and then use the footprint in the datasheet. So I'm going to start the new symbol by drawing some straight wide sides and then adding an arc on the edges and making it a semicircle. And I'll finish off the shape by copying and pasting and pressing R on the keyboard to rotate it. Next we'll add some pins. So start with pin 1 on this side. This is going to be anode, and pin 1. I'll make it a power pin. I can go here. And then I'll go ahead and add all the rest of the cathode pins to complete the tube. So now I've placed all the pins on the symbol, we should save that and start work on the footprint. Let's go to Footprint Editor. That brings up the Footprint menu. And once again, we're going to go New Library, Project, and Nixie Tube. Now we have our own Nixie Tube library where we can add a new footprint. Let's call it IN16 Nixie Tube. And this is a through-hole part. Here's a document that shows some of the physical measurements and the footprint information for the Nixie Tube. So I'm going to attempt to recreate this in KiCad. The easiest way to get started with creating this footprint is to start by placing a pad. This will be pin number 1. If we refer to the drawing, the pin diameter for the tubes are 0.4 millimeters. So we're going to make this 0.7 millimeter hole size to give it a bit of clearance, and make the pad 1.3 millimeters. Now that I've placed the first pad with the right properties, I'm going to fill in the rest of the pads. In this case, the footprint is a circle based around a radius of 4. So I'm going to copy paste the pads and add the dimensions a bit later on. Now because it's a circle, the X and Y coordinates for each pad are a bit messy to calculate, so I've made an Excel document to do it for me. Each pin is 4 millimeters away from the center, and the angle is placed evenly around the circle. So here are the X and Y coordinates for each pad. I'm going to go ahead and fill those in. Now we have a complete circle of parts, and we can double check that even by drawing a circle on the schematic and setting it to the right radius, just to check visually if all the parts align. And looks like they do. I might even keep this circle as a silkscreen indicator on the circuit board so that we can tell where the body of the tube aligns. Now you may notice that all the pads have number 1, which is not what we want. So if we go right click, renumber pads, okay, we can renumber all these pads in order so that they become unique. There we go, and save that. So now that we've finished our footprint for the Nixie tube, we can go back to the project and add the component. Nixie tube. And we'll double click on it, find our footprint, and add that. Then it's linked up to the PCB once we start building that. So now that we've finished our schematic, we're going to start work on the PCB layout. To do that, we're going to click the PCB editor button here and open that up. That's going to open up the PCB editor window. The first thing we're going to do is define the board outline of the PCB. We're going to go to the layers menu here and change it to the edge cuts layer. This should contain only the edge cut, only the outline of the PCB for the manufacturer. I'm going to draw a simple square. I'm going to make my ruler 20 centimeters long plus a little bit and 30 millimeters wide. Now we go change the layer to user drawings and click the dimension button here to add some dimensions to the design. I've got 205 on the length and 30 millimeters on the width. Next I'm going to move to the top left corner of the new board layout and start building my millimeter increments. To do that, I'm going to change the layer to front copper and then click draw a line. I'm going to make the first line 3 millimeters long and place it there. Now because we have that grid set to 1 millimeter, it becomes very easy to simply click, copy and paste this line, and it will automatically snap to each extra millimeter. I think this looks a bit messy though, so I'm going to change it so that the first length is 3 millimeters long and the next 4 are only 1 millimeter long. Now we should be able to see the progress as we make it by opening up the 3D viewer. If you click View, 3D Viewer, or alternatively press Alt 3, here's our ruler so far. If we zoom into the top left corner, you can see our lines are starting to form. At the moment these are coated with a solder mask, which is normally there to protect the circuit underneath, but in this case it makes it hard to see. We can get rid of that by changing the layer to front mask and simply drawing the exact same pattern again over the top of what we've already done. This adds a region where the solder mask will be not included. If we go back to the 3D viewer, there we have some nice shiny copper traces. Now I'll simply copy and paste these 5 lines all the way along the ruler until I've completed it. So now we have the finished millimeter increment lines. Next I'm going to add numbers to it so we can read them. I'm going to put this on the front silkscreen layer so that they're written in the silkscreen. And now we've finished the millimeter increment side with numbers. If we go to the 3D viewer, we can see now we have a nice shiny set of measurements all the way along the ruler. Next I'm going to add the inches and the 0.1 inch increments, and in this case I'm going to put them along the bottom side of the board. I've chosen the bottom side so that when you flip the board over its short edge, you'll always have the top edge aligned with whatever it is you're trying to measure. Now the easiest way to add inch increments is to first make sure that you've got your grid origin placed in the bottom left corner of the board, like so. Then change your viewing units to inches, and then change your grid units to something in inches. I'm going to use 0.05 inches in this case. And since we're working on the back side of the board, we need to go with bottom copper layer, and we can simply draw a line. And just like last time, I'm going to use longer lines for each major increment and shorter lines for each minor increment. Now we have 1 major, 4 minor. While we're here, we can also do the bottom side mask by shifting to the bottom mask layer and drawing lines over the top of our existing lines. This is what gets us the nice visible shiny copper on the back side of the board. So now we can copy and paste this all the way along until we reach the end. And that's the measurements done for the inches. Now I'm going to add the inch numbers on this side too, and I'm going to simply cheat by copying the 0 from the millimeters and repasting it here, but make sure to double click on it and change the layer to bottom silkscreen so it's on the right side. In this case, because we're flipping over the short edge, it's also going to be mirrored and upside down, so we need to change the orientation to 180 and click the mirrored button. For a 0 that doesn't make much difference, but for the 1 it becomes quite obvious. I'm going to copy and paste this across the rest of the ruler and fill in the rest of the numbers. And now we have millimeters on one side and inches and tenths of an inch on the other side. We can double check this by going View, 3D Viewer. Here are our millimeters, and as we flip it along the short side of the board, we have our inches. So now with the measurement increments placed, we can start aligning components. First we should make sure we change our grid back to metric, because that's what the rest of the board is defined in. I'm going to go 1 millimeter and change the view back to millimeters. And I'm going to change this to the front layers only so that I can clearly see what I'm working with on just this side. I'm going to start laying out my components on the front side in a nice, orderly, aesthetic way, and I'll come back and update when that's done. Okay, so I've finished placing many of the components on the front side, but I still have a lot of leftover parts to go through. I'd like to start placing some of these on the back side though, so that we have different components on different sides. To do this, we click on a component that we want to move to the back, and you can simply press F and it will flip it over to the back side of the board. We can double check this by moving the component into the ruler space and clicking View, 3D Viewer. Here we see the components on the front side that I've placed, and if we flip the board over, you can now see this diode package that I've put on the back. So I'm going to keep working on placing these components on the back side, and I'll come back when I've made some progress. Here's the progress on the board so far. Now I have components on the front side and the back side, and here's the 3D view of this. There's the front, and as we flip it over, we have components on the back. You can see I've still got quite a bit of blank space on both the front side and the back side, so I'd like to come up with some useful information to fill those spaces now that I've placed all the footprints that I think I'll need. Okay, here's the finished design. If we check out the 3D view, I can see all the footprints, and I've filled in the blank space with some useful information for designing PCBs in the future, including hole sizes, trace widths, and unit conversions. If we look at the back side, we see a similar sort of thing, but with copper thickness and some ASCII alt codes that I often use. Now that I've finished laying out the board the way I like it, it's time to run Design Rules Check. We can do that by pressing this button here, and this will scan through your design and check for any design issues that you've made. You're almost always going to encounter some issues, and in fact, here's some of mine. What do we have? Okay, so these issues tell me that I've got silkscreen overlapping other parts and objects that are too close together. If you close that, you can actually see, here we go, there's little arrows pointing to the offenders. So I'm going to fix up these little issues and try again. Okay, let's try that again. So design rule check, run DLC, and I've come back with 0 errors, 0 warnings. That's the ideal place where you want to be, so you don't get any angry calls from your manufacturer saying, how do I build this thing you've made? The next step is to export the files for the manufacturer. So we go File, Fabrication Outputs, Gerbers. And if I click Plot... Hi, Editing Luke here. I made a small mistake at this stage of the project, which I'll explain a bit later. But at this stage you should also click Generate Drill Files and include this in your Gerber zip for the manufacturer. I didn't do this, and you'll see what happened. That's generated some Gerber files for me, stored in the project folder as you can see here, and I'm going to zip these up so we can submit them to the manufacturer. I'll be using JLC PCB to make this board for me. They're not sponsored, I just like the service. They're usually pretty cheap and fairly good quality for at least what I'm looking for. So here I'm going to upload the zip file of the Gerbers and make sure to select a 2-layer PCB, add the dimensions, add the PCB quantity that you want to buy. I'm a big fan of the black solder mask with the gold coating, which is ENIG, as we see here. So I'm going to select this, even though it is a bit more expensive, I just think it makes it look much better. The rest of the settings can stay the same, and I'll click Save to Cart and go through the order process and submit it. This should arrive in a week or so, and I'll show you the final product once it's here. So here's the final product, and I'm pretty pleased with the outcome. As I mentioned earlier, I made a mistake where I forgot to export the drill layers, and this means that none of the holes were drilled into the circuit board. But in this case, that's not a big deal. You can still use most of the features of the ruler as is, and all the information is still there. Overall, this was a great learning experience for using KiCad to create a PCB, and I hope that you've learned something useful in this video. Maybe you can go out and make your own PCB ruler now, without making the same mistake I did. So thanks for watching this video. Let me know what you think in the comments down below. If you like this, give it a like, and if you want to see more cool electronics projects in the future, consider subscribing. Cheers.